everyone, and welcome to our science experiment. Today we will going to explore an exciting chemical reaction right before your eyes. We will be creating a volcano using just baking soda and vinegar. This experiment is not only fun but also a fantastic way to understand the interaction between acid and bases. Before we dive into experiment, let's talk about the science behind it. We are dealing with an acid-base reaction. In this case, our acid is vinegar, which contains acetic acid CH3COOH, and our base is baking soda, which is sodium bicarbonate NaHCO3. According to Bronsted theory, an acid is a proton donor and a base is a proton acceptor. When they react, they producing water, a salt, and carbon dioxide gas. Let's move on to the experiment. Here's what we need. First one is a baking soda, and then second is vinegar, and 3 is a bottle of a small container. I want to use a small container. And then other thing is a paper towel and tray to catch the overflow. First, we take a piece of paper towel and put 2 or 3 tablespoons of baking soda in the center. And also I want to use the measured spoons. Three. Next, we wrap up the baking soda with a paper towel and make a small pocket. This packet will slow down the reaction when we add the vinegar, allowing us to observe it better. Now we place the baking soda packet into the bottle. This one, bottle. Then ready to pour the vinegar into the bottle of the watch the reaction happen. But remember, safety first. Make sure to wear safety goggles to protect your eyes. Okay, first, okay. I'm ready to pour the baking soda packet into the bottle. Okay. And then I pour the vinegar into the bottle with baking soda. Pay close attention to the reaction. Notice the immediate freezing and foaming. That's a carbon dioxide gas being released. The reaction creates so much gas so quickly that it pushes the liquid out of the bottle, creating our volcano effect. Look at how the mixture is bubbling and overflowing. This is a crazy example of an acid and base reaction. The carbon dioxide gas produced by the reaction is what causes the dramatic foaming effect. It's the same principle that makes a freezing drinking bubble. To wrap up, our experiment today showcased a simple yet fascinating chemical reaction. It demonstrated how an acid and base react to form a gas, which can create an impressive visual effect. The experiment is a great reminder of the wonders of science that surround us in our everyday lives. Thank you for watching, and I hope you found this presentation both educational and entertaining. Thank you. In this limiting reactant, in this experiment, it depends on the stoichiometry of the reaction and the initial amount of vinegar, acetic acid, and baking soda, sodium bicarbonate used. Typically, in a setup like this, baking soda is in excess, wrapped in a paper towel, which slows its reaction with vinegar, making vinegar often the limiting reactant because it gets consumed first, determining the extent of the reaction. Hello everyone, and thank you for joining me today. I am excited to share with you an exciting scientific demonstration that showcases the principle of chemical reactions through a fun and interactive experiment. Today we will going to simulate a volcanic eruption right here in our classroom. Our main objective is to understand how certain chemical reactions can produce gases and how this concept relates to real volcanic eruptions. By the end of the experiment, you will see how science can be both educational and incredible fun. For our experiment, we will need a few simple items: baking soda, vinegar, plastic or glass bottle, paper towel, measuring cup or spoon, and safety goggles and tray. Okay, and then you already saw our experiment procedure, so I'm gonna skip this file. So we can make the definition of Bronsted acid and bases. Bronsted acid is a substance that donates a proton Hc plus ion in a chemical reaction, while a Bronsted base is a substance that accepts a proton. This concept is crucial for understanding how the reaction between acetic acid and sodium bicarbonate occurs. Acetic acid, CH3COOH, is a weak acid found in vinegar. It can donate a hydrogen ion to a base. Sodium bicarbonate, a common base found in baking soda, can accept this hydrogen ion. When these two substances mix, then undergo an acid-base reaction. Reaction formula like that. We have to understand the roles in the reaction formula. Acetic acid acts as a Bronsted acid because it donates proton to sodium bicarbonate. Second one is sodium bicarbonate functions as a Bronsted base because it accepts a proton from acetic acid. So, products of the reaction: sodium acetate, CH3COONA, formed as a result of proton transfer from acetic acid to sodium bicarbonate, showcasing the conjugate base of acetic acid. Second one is water and carbon dioxide. Water is produced from the combination of the donated proton and hydroxide ion from the bicarbonate ion, and CO2 gas is released as the bicarbonate ion loses hydrogen ion and decomposes. These experimental results and observations are foam production. The gas bubbles are trapped by the liquid mixture, creating foam, and then release of CO2 gas. The bubbling is the visible release of carbon dioxide gas escaping from the liquid solution. The dramatic forming and overflow resemble a volcanic eruption, hence the experiment's popular name, volcano experiment. This phenomenon occurs because the solid sodium bicarbonate reacts with the requisite acetic acid to produce a gas, CO2 gas, a liquid, H2O, water, and a soluble salt, CH3COONA, demonstrating the characteristic gas evolution reaction in an acid-base context. The form is essentially a mixture of the produced water, carbon dioxide bubbles, and the remaining liquid vinegar, visually demonstrating the classic acid and base reaction in the engaging and educational manner.